I got 14, 12 I got 36, 16 I got 34, and 20 I got 29.
That's correct. Boom. How'd you do it?
Well, I realized from 0 to 4 it goes up 7, and then from 4 to 8 it goes up 4. So that is a -3 increment. And then I went back and did retrace the steps to get -8 to 14. The g of x goes up 13, which will make that one go down 10, which will make the next one go down 7, and then 4, and then 1, and then -2, and then 5. So it goes down 3 over time.
Perfect. So the key there is we know we're looking for a quadratic function. What we learned yesterday is quadratics have a common second difference. And so right here is my biggest group of numbers together. Right, so we can find the first difference. How much did I change to go from 24 to 31? I went up 7. How much did I change to go from 31 to 35? I went up 4. Right, but I have nothing else to really fill in other than that. But now because I have back-to-back first differences, I can find the second difference there. If I went from +7 to +4, that's a loss of 3. And because it's a quadratic, I know they all have to be losses of 3 all the way through there. So what had to be here, if I went from 7 to 4 in this direction, just think 4 to 7, I gotta go back up to 10. That way it's still a loss of 3 from here to here. And this has to be 13, so it's a loss of 3 from here to here. And then once I know this value, if it was 1 and I added 13, it has to be 14. If it was 14 and I added 10, that works with 24, right? And then we just continue these. So then if I lose 3 again, +1. If I lose 3 again, I'm at -2. And if I lose 3 again, I'm at -5 for the first difference.
How do you know to start out with +13?
I didn't know that to start with until I found this. So as soon as I know the second difference is -3, that means every time I go from here to here, I'm losing 3. So vice versa, to go from here to here, I'd have to add 3. So I need to add 3, then I would add 3. So the first one I'd find is 10. And then I would add 3 to get to 13. Right? If I had to find the one before that, right? Assuming this is -12, how much did I go from? It would be a +16 there. So that means this would need to be -15. If I created another point. I could keep finding them. This is all, and again, we didn't mention this. This is all working because what kind of intervals do I have in the domain? Equal intervals of my domain, yeah. They're all increasing by 4.
With 18, you would just minus by 1.5, right? Would you do that? Or
You can.
would it be minus 1.5?
Yeah, for the second difference. So you have to go find the first difference. It wasn't worth it.
So it'd be minus 3.5 of 34, so it'd be 30.5 would be 28. Or I mean 18. Yes.
You kind of understand this, or got questions on this? It's a great question. It's something you might see on your test. Right? That's fine. Do you have a question about it? Because we're not going to look at this again before test day. Okay, so the today's lesson is, first we're learning all the different parent functions. And you guys told me you were familiar with the parent functions? Yes? Okay. We'll see if our definitions, maybe you'll be more than familiar. Maybe you'll knock it out of the park. That's what I'm hoping for. So the first graph here, we're going to draw them, and then we're going to state some key points, and then identify some key characteristics of it. So here's my first parent function, f of x equals x. What does that look like graphically? Okay, well, all lines are straight. It's not horizontal. It's not vertical. It's a line with a slope of 1, right? It's y-intercept is 0. Okay, we said it was a line with a slope of 1, y-intercept is 0. That makes me feel good about the rest of these, that you guys get that one so easily. That's the most basic one. What are some key points for this graph?
Probably like 1, 1.
Yeah, I like 1, 1.
3, 3.
I don't like that one. I like 0, 0. I like -1, -1. I personally like to have 5 points, so I'm going to do 5 points on all of these.
Probably like 3001.
3001 could be, but I'm just going to go -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. Okay, this is something that I think that we are normally terrible at by the time they get to me. Just awful. Identifying the domain and range. Can you guys tell me what the domain and range of this function is by looking at it?
Yeah.
Can you? Okay, good. What's the domain?
Negative infinity to positive infinity.
That's true. You be okay with that?
Yes.
What's the range?
Negative infinity to positive infinity.
That's true too. Good. That gets me excited. X-intercept.
0.
Y-intercept.
0.
Where is this increasing?
Everywhere.
Everywhere. So where's this decreasing?
Nowhere.
Never. Questions on that one? Second one is the absolute value of x.
Looks like a little V.
It is a v.
Oh.
What are 5 key points for this graph?
Probably like -1, 1. No, yeah, -1, 1. Negative 1, 1.
Are we going to keep saying the same point? How many? -1. 1. How many different inflection ways can we do the same point?
0, 0.
0, 0, 1, 1.
-2, 2. 2, 2.
I mean, I get you want to be a ballerina, but that's okay. What's the domain of this graph?
Negative infinity to positive infinity.
I only heard one person that time. Do y'all agree with Jack Riley? You gonna let him speak for y'all? Okay. What's the range?
0, 0.
Yeah, and the 0 is included, right? Because it actually reaches 0, so that 0 should be in a bracket. It's okay with that? X-intercept.
0.
Y-intercept.
0.
Where's this increasing? From 0 to infinity. Where's this decreasing?
Negative infinity to 0.
And remember, increasing and decreasing, we never have brackets. It's always parentheses on those. Questions there? Next one, x squared. What's the graph look like? Is a parabola
Wait, what was decreasing on last week?
Negative infinity to 0. Wait, what?
What are some key points of a parabola?
0, 0.
Smart.
Sure.
Smart.
I wonder if you get
Negative
over
1, 1. Is that true?
4.
2, 4?
Negative 2.
Ooh. 1, 1.
What's the domain? What's the range?
0 to infinity.
X-intercept.
0.
Y-intercept.
0.
Where's this increasing? Where's this decreasing?
Negative infinity to infinity. And then 0.
Here we go. X cubed graph.
Is this squiggle?
Snake.
Gary the snake.
Gary the snake. What are 5 key points?
0,
0,
0.
0.
1,
1,
1.
1.
Negative 1, negative 1.
-1, -1.
2, 4 again.
It's not 2, 4. 2, 8. And -2, -8. So whenever I'm finding these key points, these are the x values I like to plug in. If it makes sense, I plug in these 5 x values every time it makes sense to. Right? And how can I find the y value? Just plug in. What's -2 to the 3rd power?
Negative.
No kidding. Right? That's all this is. Okay? So if you get confused, no, I want to plug in those 5 points. -2, -1, 0, 1, and 2.
73 is 27.
Anyways, where's the domain? Or what is the domain? What's the range?
Negative infinity.
X-intercept. Y-intercept. Where's this increasing? Everywhere. Where's this decreasing? It's never decreasing. Never decreases.
This is a positive guy.
Well, it's not positive.
He's increasing.
Yeah, but it can be negative.
He's a positive guy. Sorry.
So you're saying this half of him doesn't exist?
No.
Okay. Well, you said he's a
He's
positive
positive.
guy. This is positive over here. This is negative right here.
I don't mean positive. I mean minus.
Oh. Oh. Next one. Square root of x. What shape is this?
Square root shape.
It's a square root shape?
Oh, I thought you said yeah. This on
I like the hand motions.
Square root's like this. It's like a.
Like this?
Thing, maybe.
Wait, no, it's opposite.
Are you just going to come barging in here?
I'm not.
After you... Okay, if I had to explain that verbally, I think I would say half of a sideways parabola.
If you had it right, you just didn't push it.
I didn't crook it enough. Okay, so I got half my sideways parabola. What are some key points to this graph?
0, 0.
That's a good one.
1,
Huh? 1-1. That's a good one. 2-1.
No.
2-1?
Your line's going through 2-1.
No.
It should be going through 1-1.
2-4.
I may have messed up,
No,
made it go through
4-2.
2-1 also.
4-2.
4-2.
9-3.
9-3. So why did we not pick -2, -1, 0, 1, and 2?
Because if you look at it, there's
No kidding. If you look at it, we've already drawn it. What am I doing? I'm taking the square root of something. Does it make sense to take the square root of a negative? No. So let's don't pick -2 and -1. Does it make sense to take the square root of 2? If you like ugly numbers, like 1.414. I give. See if I'm right. You don't think that's a trick? You never had radical 2 over 2, your special right triangles? 30, 60, 90, 45, 45. Let's go. Wake up. Get in the game. Hope. What's my domain here? 0 to infinity. Include 0. Don't include infinity. What's the range?
0 to infinity.
0 to infinity. Include 0. Don't include infinity. Where's the x-intercept?
0.
Where's the y-intercept? Where's this increasing?
Everywhere. 0 to infinity.
That's not.
Where's this decreasing?
Never.
Never.
How come you don't include the 0?
We never include endpoints on increasing or decreasing.
It's just a rule.
But you read it from the left to right.
Yeah, you're right.
Because
Not
it's, I mean, if you think
You're
about it, kind of, it starts increasing.
Yeah, it starts increasing right after 0, but when it begins, there was no increase, which is...
It's like 70 outside.
It's like one of the most mysterious ideas ever. Like I can relate it to in the beginning. Amen. In the beginning. What do you mean? I'm confused. I caught two. I get confused.
It's pretty decent size fish. 3 and 4.
Okay, the last one. This is my least favorite parent function. The reason is we're going to do a whole big unit, like 2 weeks, focusing only on this parent function. And I like doing that version of the rational function better than I like doing transformations with it. So just know this is going to be the one we're going to use the least initially until we have those special 2 weeks on it. So anyways, this is called the reciprocal function. I guess I should have named all of these. I forgot to tell you the names. Oh, well, it doesn't matter. You don't care. What does this look like? Triangles?
What?
They don't touch the origin.
Does it actually look like that?
No, absolutely not.
not.
This is not a function.
It's like,
One, it goes like this way,
I'm quitting.
and then the other one in the top.
Because they don't touch the.
Yes, asymptotes.
Oh.
But not only are there asymptotes, there are also right. They have to also pass the vertical line test because we're dealing with functions, right? So that's why I knew triangles was a bad answer.
because that wouldn't pass the vertical.
It would not. I do not know a single triangle that would pass the vertical line test.
Maybe in isosceles triangle.
If you can come up with a triangle that would pass the vertical line test, you pass the class. Yeah. The problem is people will spend more time figuring that out than they do their homework, where they actually need to practice this. Yeah. It can't.
What if I just look it up on Google and it pops up
Yeah. Yeah, AI can do all kinds of crazy crap, so I don't know. Okay, what are some key points to this this rational function? D. I'm gonna go with 1, 1. My graph didn't go through it, but just ignore my graph. I was working too much about the asymptotes. Also, like -1, -1. What if 2 was my x value? What should be my y value?
2.
It's not 2.
4?
Should be 1/2. You guys not know how you plug in? I told you, plug in. I could plug in -2. I would get -1/2. Yeah, I like plugging in 0 too. Why does I plug in 0?
0.
But it doesn't pass through 0, so.
Joy!
Undefined.
So when x is 0, it is undefined, which later we're going to find out that means there's a vertical asymptote there, right? And you guys have already mentioned the word asymptote, so we'll get there when we get there. What's the domain of this function?
0, negative infinity to infinity.
No. Negative infinity to 0.
And then
And then union 0 to infinity.
And it broke my brain.
Would you say why I can't include 0? Domain is what am I allowed to plug in for x and be okay? Well, I can plug in anything I want to for x except 0. Why? Because it causes a divide by 0 error. There are two things that make our domain not all real numbers. There's only two things. If I can divide by 0, I have to account for that. So because this is our first one with a fraction, I have to account for divide by 0 error. What's the other thing we can't do? Look back at what else affected our domain. Find one that the domain wasn't all real numbers. Right above it! What's the domain?
0 to infinity.
Why? What caused that to not be negative infinity to infinity?
There was an endpoint.
Why?
Because it doesn't actually touch.
Why?
Because you can't.
Forget the graph.
Oh, you can't have negative.
Square root of negative.
You can't take the square root of a negative, okay? Those are the two things that will break the domain, that causes the domain to not be all real numbers. Divide by 0 errors and square root of negative errors. So anytime I ask what's the domain, I look for two things. I say, can I divide by 0 in this equation? If the answer is no, then I say, can I take the square root of a negative? If the answer is no, then it's all real numbers. Every time. All right? I just have to account for those two exceptions. What's the range? The list of y values.
Negative infinity to 0. Union infinity to 0.
That's it. What's the x-intercept? There isn't one.
Wait, what?
There isn't one. Where does it cross the x-axis? It doesn't. So where's the x-intercept? There isn't one. Where's the y-intercept?
None.
There isn't one.
It gets really close. Right?
Yeah, good try, good effort. Yeah, but no, there isn't one. It gets as close as it possibly can be.
But no signal.
That's right. That's the LeBron James kid. You know, I'm talking about he got beat in the finals against, it was like 2011. They're losing a game in the finals. And they're walking off into the locker room. And you just hear one little kid yelling at all of them, good try, good effort, good try. I'll look it up in a second. It's like those poor pro guys, they don't want to hear that. It's like he been to me Little League games. Okay. Where's this increasing? Where's this decreasing? Everywhere but 0, it's decreasing. Which parent function or functions has a constant rate of change?
F of x equals x.
No kidding. The one that's linear. Any other ones have a constant rate of change? No, they don't. Well, you could make a case that that's the value of x. It's not constant everywhere, but it's in 2 pieces, and I could make each piece have a constant rate of change. So I don't know what they answered, but you could kind of make a case there because that's basically 2 lines. Anyways, 2. Can you identify the parent function of each of the following equations? So if f of x equals 2 over x minus 3, which is my parent function?
F of x equals 1 over x.
Yep. Is everybody okay with that? Everybody? Next, g of x equals 4x squared plus 5x cubed minus 1.
F of x equals x cubed.
That is also correct. Take the highest powered term. C.
F of x equals absolute value x.
Very good. Questions? 3, A and B. I want to know if this is linear. Three A, is that linear?
No.
How do you know?
Because it goes from -5 to -3, and then so that's a jump of 2 or a jump of 2, and then
Okay.
it's a jump of 4.
I have equal changes in the input. Right? Does that produce an equal change in the output? -2, -4, -6, -8. So it's not linear. Is it quadratic? How can I tell if it's quadratic? The second difference. To go from -2 to -4. Down 2. From -4 to -6. Down 2. From -6 to -8. Down 2. I have a constant second difference. That means this one is quadratic. Look at B. Do I have common differences in the domain, in the inputs? Well, sometimes I do, right? I've got plus 0.5, and then I got plus 1. So let's skip the plus 1 one for right now. Then I got plus a half, and then I've got another plus a half. So let's focus on only the ones that have equal jumps in the input. So really that's happening down here mostly. So then let's look at the changes in the output. To go from 86 to 92, that was up 6. From 92 to 98, that's up. Okay, so that looks promising. What about to go from here? What about from 62 to 70? That was also plus a half. That one went up 8. So it's not linear.
It's not quadratic. It's probably neither.
And I don't have enough information to tell me if it's quadratic or not. Right? I can find this second difference. It's 0. But I don't have anywhere else I can find another second difference. Right? So I don't have anything to compare it to. Questions? 4. I don't care about that. So do you guys remember doing transformations of parent functions? Shifts up and down, shifts left and right, stretch or compress, reflection. Okay, all of those. So that's what's going on here. So I'm going to focus on, this is true for every parent function we just talked about, okay? But I'm going to focus on the quadratic function, second degree. So x squared. You could just replace that with 1 over x, with square root of x, with x cubed, right? But that way it's just, we're all talking about the same thing here. How can I make this have a vertical shift?
You add in the parentheses, right? 'Cause
It's not in the parentheses.
it's
This one's
outside.
outside the parentheses. So here's my little,
Horizontal shifts.
yes, here's my little cheat, or the way I remember things. I say the transformations either happen inside the function or outside the function. That's not technical. That's my Sand Mountain coming out. Okay? It's either inside the function or it's outside the function. If we do something to the inside of the function, that affects the x values. If we do something outside the function, that affects the y values. And hopefully you'll see what I'm talking about as we go. Also, whenever I do something inside the function that affects the x's, it does the opposite from what it looks like. All right, that's me. I'm going to Sand Mountainize this. That's only when it's the inside that affects the x's. What your brain wants to tell you it does initially, it does the opposite. We can talk about why, but I don't have time right now to talk about the why. Okay? We just got to try to knock these out.
Opposite goes right if it's positive.
That's right. So vertical shift. Vertical is which direction? Up and down. Up and down affects the y's, so it needs to be on the outside of the function. So it would look something like this. X squared plus or minus. I'm just going to put plus or minus. Is everybody okay with that? That means it could be plus 4, could be minus 4. Those are both vertical shifts. When would this one move the graph up? If it was plus 4. When would this move the graph down? Are you okay with that? Horizontal shift. Horizontal is left or right, so it has to happen, it affects the x's. So that's happened on the inside. So that would be something like x plus or minus 4 squared. Everybody's okay with my notation still? I'm just trying to save us time. When would this move right? When would this move left? Opposite from what you think it should be. Right? What it looks like. Vertical dilations. This is sometimes called stretch and compress. Dilate. You know, have you ever had your eyes dilated? Make your pupil really big. Really small. It makes it really big and it's super bright.
So there's a fraction outside the parentheses.
It doesn't have to be a fraction. So vertical is talking about the y's. So if I affect the y's, it needs to go on the outside. So it needs to be, I'm gonna say this time. I'm gonna say a times x squared. It could just be written as ax squared, a times x squared. Okay, that's on the outside. Because is the a being squared? No, only the x is being squared. Okay? That's how we know it's on the outside. When would this stretch the graph?
If you put 4 in front of the A,
Not in front of the a. If I put 4a. 4 in place of a would stretch it. What else would stretch it? Yeah, positive that's tricky. Let's don't focus on positive or negative right now. Because the negative will do something different.
Maybe hold on.
If A is bigger than 1, it stretches it. So if it's 2, 3, 4, 5, 6. But also, if you see a -2, a -3, a -4, a -5, -6, I want that to also stretch it. But the negative reflects it, right? And we'll talk about that. So here's the technical. I'm talking you through it. Here's the way you really write it. If the absolute value of A is bigger than 1.
I was just about to say that.
Yes, that's where we were getting. Okay? The negative does something else, so I don't really care about the negative. But any number bigger than 1. When would I shrink it or compress it?
Absolute value of A is greater than 1. Less than 1. Yeah. I wrote my little thing.
But it also has to be bigger than 0, right? I'm not going to write that on there, but 0 is less than 1, but 0 makes it not even the parent function it was originally, right? So 0, you're never going to see one that's 0, but technically it has to not be 0 too. Horizontal dilation. Horizontal affects the x's, so it has to be on the inside. And so when would this stretch? When would this be a horizontal stretch?
It's opposite, so when it's a fraction.
Yes. When it's a fraction, it's a horizontal stretch because everything on the inside does the opposite from what you think it should do. So it would be the absolute value of A is less than 1. It'll stretch it.
But it's greater than 0.
Yeah. Yep, same reasoning. Again, you're never going to see A be 0. Because if A was 0, like think about it. If this was 0 times x squared, what's 0 times x? 0. Square it, 0. I don't even have, it's no longer this parent function anymore. So they're not going to be super tricky. But if you had to really define it, you have to say it can't be 0. When would I shrink or compress the graph?
Absolute value of A is
Bigger than 1. And then the reflections, okay, here's the way I have to think through it. If I want to reflect over the x-axis, what's changing if I reflect over the x-axis? If I had the point 3, 5, and I reflected over the x-axis, what point am I at now? 3, -5. So reflection over the x-axis changes the values of the y. If I need to change the value of the y, it needs to be on the outside. See how I can think my way through all of that. So this would be, if I have something like -x squared, let me go real quick. Changes value of y. And then if I have something like -x squared, that's on the inside, right? Inside affects the values of the x. So it's going to reflect over the y-axis. So this changes value of x. And I'm done.